Hello geometry students, and welcome back to another video lesson as we continue to look at area of different types of quadrilaterals. Yesterday we focused on triangles. Today we get into quadrilaterals, or the four-sided shapes. So, again, a lot of you commented that this was a little bit small, hard to see. Totally get it, totally understand. If you would like a copy of this or the ability to make it larger, just shoot me an email and I'll attach this as a copy in the email. But yesterday we focused on these three triangles, right? Area equals 1/2 base times height. Today we are going to focus on the parallelogram and the trapezoids. So we're going to come up with just those two for today. So let's start with the trapezoid. And this works for either isosceles or just a regular trapezoid. The formula is 1/2 times the height of the trapezoid times the group base 1 plus base 2. Now, it does not matter which one we call base 1 or base 2. We could interchange them because really we're just adding them together anyway. And recall that those bases are parallel to each other, right? Those are the parallel sides. That's what makes it a trapezoid. Now, similar to the triangle that we talked about, the height must be perpendicular to both bases in this problem. So sometimes they'll give you a number out here. I'm just going to label this slant as x, but that's not the height of the trapezoid. We have to use that altitude on the inside where it is perpendicular to both bases. So let's take a look at an example where we're trying to find the area of this trapezoid. So again, this line on top is parallel to this line on bottom. Therefore, this on the inside, because they're parallel, this makes that 90. This is our height. Come on, height. And we'll just label the top one as base 1 and the bottom one as base 2. And really, we're just going to plug them into this formula and then follow the order of operations. 1/2 times our height, which is 6.3, times base 1, which is 8.5, plus base 2, which is 4.7. So you can follow order of operations, do these one by one, or you could also go to Desmos and type in that whole line into Desmos if you wanted to as well. Either one of them is okay. If I add those two together, I get, what is that, 13.2 times the 6.3 times 1/2. And so that's all being multiplied. So we can do that all in one step. So half of 6.3 times 13.2 gives me 41.58 units squared. All right, but again, the key is identifying that height, knowing that it's that perpendicular to both bases in a trapezoid. Pretty straightforward formula. Now, we're also going to be asked to work backwards, though. Okay, an isosceles trapezoid has an area of 144 square inches. The altitude measures 9 inches, and one of the bases is 20. Find the measure of the other base. Right, so let's just draw ourselves a trapezoid, and let's just say, I don't like that, so undo that. Whoops, come on. We want a trapezoid. So let's just say that we have the isosceles trapezoid that looks like this. Base 1, base 2, and this line right here is that altitude or the height. So this is 9. One of the bases is 20. Find the other base. Let's label that as x. So area equals 1/2 height base 1 plus base 2. And let's fill in this formula, the information that we are given. We're given the A value. We're given area is 144 equals 1/2 times the height. We're given that height. They tell us it's the altitude. That is height. So 1/2 of 9 times base 1, which is 20, plus the x value. So we can't really do anything in here with x and 20 until we get it isolated. Well, we can take 1/2 times 9, that's 4.5, and then we've got times 20 plus x, and that equals 144 on the other side. So how do I get that parenthesis by itself? How do I move the 4.5? We divide. So we need to figure out, excuse me, what is 144 divided by 4.5? 32, or 32 equals 20 plus x. How do we undo that 20? Well, we would subtract the 20 from both sides, subtract 20, meaning x would equal 32 minus 20 is 12. That missing side would be 12. Now again, the picture's not accurate. I could flip around the 20 and the 12 because base 1 and base 2 are interchangeable. But I hope you see how we worked backwards through that problem, knowing the formula for area of a trapezoid. Let's move on to the parallelogram. The nice part about a parallelogram is that basically it's base times height, right? We've got this common theme, though, that the base and the height, they need to be perpendicular. They've got to be perpendicular. Now, the reason this works is, imagine if I chopped this triangle off over here and I just said, you know what, I'm just going to move it over here. Well, all of a sudden, we created this square or a rectangle from the parallelogram. Right? So that's why the formula is the same as a rectangle. But again, be careful because they will give you some of these slant measurements, and those aren't the heights. The height is from the altitude that connects the base. It's got to be perpendicular to the base. So let's see if we can't find the area of this parallelogram. Again, area is base times height. What's the base? Well, the base, we might want to wait. What's the height? The height is 6.4. And how do I know that's the height? Well, that's because of the right angles. There's those perpendicular numbers, or those perpendicular relationship, right? Perpendicular to the bottom, perpendicular to the top, which means 10.8 is my base. 10.8 times 6.4. We don't need 8.5 for the area of this one because it's not connected to the height. The 8.5 would help us find perimeter, but not area. So we're going to go to our calculator or Desmos or whatever you're using and taking 10.8 times 6.4, and we would get the area equals 69.12 units squared. All right, so I think the tricky part here with parallelograms is that you got to make sure you identify the height correctly. Last example, let's work backwards with parallelograms. Parallelogram has an area of 50 and a base of 25. Find the altitude, which is the height. So area equals base times height. Let's fill in what we know. We know the area is 50. We know the base is 25. We are looking for the height or the altitude. How do I solve for h? We divide by 25. 500 divided by 25 should be 20. So our height or our altitude is going to be 20 meters. 20 meters. If you have any questions on trapezoids or parallelograms, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.